I tell stories with pictures. Specifically, my pictures are science pictures. But the idea behind it is that my hope is that if you think about innovation, something that has to come to your mind is communication with each other. If we're going to collaborate, we have to talk to each other. I suggest that we're not using pictures enough. Drawings. It's how I think my world is. I have the best job in the whole world. I work with some pretty amazing scientists and engineers, and we talk to each other on the back of the envelopes with drawings and pictures, and that's how we communicate. Goethe's a little famous today. That which we know, we have first seen. I'm not going to be saying anything brilliant. This is incredibly obvious to me. It's about communication with a vocabulary, a visual vocabulary that we can all at least try to comprehend. I happen to take pictures and look at science. And I suggest to you that seeing science and making the visual representation of that science clarifies the science for the person making the picture or the drawing. It's not only to communicate to you all who don't understand it perhaps, but it's also for me to clarify it in my own mind. It's like writing an article. I have to figure out what it is, what is the essential piece in my image that I want you to see. It's a very exciting place of intersection among disciplines. You know, of course, that research is becoming incredibly interdisciplinary. The biologists are working with the physicists. It's that place with pictures that we could at least start talking to each other. It's also amazingly wonderful. I've been working with students at MIT for them to become more engaged with concepts. Now, there's a very important piece there that I want to suggest. It's not just about taking pictures for yourself. It's taking pictures or drawing for the purpose of communication. You want to tell a story in that image so that the other person can get it. It's different from making a picture for your own notebook. And ultimately, this is my eternal soapbox, I am desperately involved with trying to get the whole world turned on to science and engineering, because that's how we're going to make intelligent decisions about stem cell research, for example. You have to know what in the world we're talking about. I suggest it's with pictures of science that we're going to at least make that attempt. I'm going to run through a few for you. I'm not going to get into heavy detail, but you have to believe me, this is not decoration. This is true science. This is about research. And sometimes, in this case, this is something called ferrofluid. You're looking at a glob of oil, very important word, glob. And under the glob are 7 circular magnets, and you're seeing the effect of magnetism. I could get into it deeper, but I took this picture for a book that I did with George Whitesides called On the Surface of Things. The idea is to get you drawn into this and basically say to yourself, what in the world is going on here, and to ask questions. Here you're looking at liquid crystals that Nick Abbott is working with. These are microchannels that people are starting to, these are 50 microns, if that means anything to you. By the way, that whole issue of scale is something I'd like to talk to some people about. But they're embedding microchannels in plastic so that we could do some sorting of cells and we can bioassay things. It's all about technology, but ultimately it's about science first, bringing in ideas to technology. Here you're looking at what some think are sand dunes. I think it's quite amazing that you're looking at bacteria growing in their own patterns. They've actually self-assembled into this glorious, glorious pattern. Here you're looking at nanowires. Charlie Lieber is using what's called the bottom-up method. This is not nanotechnology because nobody's using this yet. Be careful of that word nanotechnology. You're seeing it a lot. It's mostly about nanoscience at this point. It eventually will become nanotechnology, but these wires, which are amazing that Charlie did, are not really used at this point. So I'm just trying to alert you to using that word. And this is a book, this is an image I took for our book, again, on the surface of things. And this is really to talk about what a hydrophobic surface is. It's about, you know, when you wash your car and you wax it, the water beads up. Well, this is about hydrophobicity. The idea is to get you to ask questions. I, by the way, must work with writers, of course. My stories are never complete without text. And luckily, I'm delighted that I have enough of them around me. This is about Scotch tape, sticking. This is a piece of tape under a microscope as I'm pulling it away, and you see these fingers, and those fingers change depending upon the substrate. Sticking is about adhesion. Adhesion is about paint and Scotch tape, but it's also about cancer cells. When they metastasize to other organs, they stick. There is, in fact, a connection. This is what I try to do, is create these visual gotchas for people who really don't think of those connections. They really exist, I promise you. This is a detail of a micro rotor. We're making some amazingly small things these days. And this is a story about self-assembly. If you look carefully, you're seeing small pieces of plastic. Those are 3 millimeter pieces that are swimming between two liquids. And when you stir it up, they literally find each other. They self-assemble because of the nature of the chemistry on their sides. Again, I could get into more chemistry, but this is about, maybe you'll start asking questions about self-assembly after looking at this. And here is crazy. It's buckling gold. This is all experimental, by the way. These images were used in submissions. You're seeing a very, very thin layer of gold on plastic. And when the plastic contracts, look at how the gold is buckling in mostly a herringbone way. But you see where those round spots are. Those round spots are pieces of gold that were incorrectly deposited. So the presence of those gold pieces are affecting the buckling. They're becoming more radial. This is a mistake. Mistakes are the places where we find out what the science is about. And this was, in fact, published in Nature. This is about block copolymers. It's a disc that's about 1 centimeter wide with stuff inside it. Let's just leave it at that. It's a sandwich of glass. This is the same sample 24 hours later. And what's going on is you're seeing a change of light. It's called iridescence. Block copolymers form various wavelengths. And that's what you're seeing when you see iridescence in butterfly wings, for example. I threw this in just for the hell of it, because on the back burner of my work, I'm working on a cookbook that is mostly the science of cooking. And there are a lot of wonderful books out there. I happen to love to cook. But none of them are very visual, which is something I'm a little surprised about. This is about hard-boiled eggs. And hard-boiled eggs go through some serious chemistry when you cook them. And here is an image that I just made of this amazing thing. Look at the detail. This is a sponge that is, it's actually a glass. It's made out of glass. Look at the incredible intricacy of the pattern. Nature knows what she's doing. This is Joanna Eisenberg's work. So what I try to do is get the researchers to think about making images and illustrations that are more than good enough. Okay, Nick Abbott made this image, an out-of-focus image, of something called a self-assembled monolayer. What you're looking at are drops of water that are taking on a shape. The reason why they are shaped that way is because there are lines on the surface that are hydrophobic. That you drop the water on and it stops right at the line. That middle one is about 4 millimeters across, so that you have some idea. So I said, well, first of all, look how it was used. Fine, in Science magazine it was published and it said what it had to say. I said, let me try it, and this is what I did. All I did was, number one, asked for a different pattern, give me a hydrophobic grid, and what if I colored the water before I placed it on the surface to emphasize what is going on here? And ultimately, this is what happened. This is out of Whiteside's lab. Okay, what happened here was, in my opinion, I made the communication a little clearer in the sense that you do not see that water melding together in my picture. That's the purpose of the hydrophobic line, so that it shows you that the water stops right there. In Nick's picture, you couldn't really say that. In my picture, I say to you, you see, they're not blending together. Those colors are discrete. And I believe not only perhaps am I helping to bring attention to it, I'm also communicating more. Here is an image that, and I'm plugging my book, The Audacity of Me, Envisioning Science. Here's an image that I thought was going to make the cover of Science, and it didn't, because the editors felt that the way I lit it was ambiguous. You see there's two colors of greens and two colors of purples. But that's a very, very important thing for me to have gone through, because I am not an artist. I am a visual communicator. I don't want me to be in the pictures. I want you to see the science that I want you to see. So More Than Good Enough is this lousy picture I made of the Marangoni effect. I think it's lousy when you twirl the glass of wine and you see the tears. Well, this to me is the better picture. It is the shadow of the Marangoni effect. But once again, of course, you do need text to go along with it. When I work with researchers, I just give them choices. That is, those are the identical shots, just different light. One of them might be more than good enough. These are about bubbles that are growing between two pieces of glass. All I'm doing is moving 5 inches to the side, and I get a completely different image. This is the identical thing. This is about your perspective. You have to figure out what is more than good enough. I promise you the next 4 images are the identical sample. It's, again, an assembled thing, a self-assembled structure. Let's call it just that. All I did was move the camera, or the sample itself, or the background. These are all the same. It's about perspective, and you have to figure out which is the best, or maybe they all are. The same with a Morpho butterfly wing. You know that the Morpho butterfly does not have blue dye. The reason why you're seeing blue is because of the structure of the wing. The light reflects off of the wing only blue wavelength, and that is the purpose, that is the reason why you're seeing blue. This is a detail just taken with a camera and a lens. Now I'm getting in with a scanning electron micrograph, which I've colored, and as you see, you're seeing these holes. It's called periodicity, and what's going on here is when the photons hit it, the wavelength reflected off is blue, and for that reason, that's why you're seeing blue. And this is about scale. I'm trying to get you to understand the scale by giving you some sort of context by starting from one spot. Okay, let's go quickly. I'm showing you individual images of one thing, just one right after the other. You're seeing a sort of an animation, aren't you? That is, in fact, what animations are. It's a series of still pictures. I suggest that maybe we shouldn't be so taken with animation all the time, and that maybe looking at each individual image side by side can perhaps give us more information and describe it better to us. But in the end, whatever I do, and whatever any of us do in science, we must maintain the integrity of the science. When you look at something like this, you have to say to yourself, this is dead wrong. But it becomes an icon. Images that can become highly iconic. We have to be very careful. This is not the story of evolution. And when I color an SEM, I ask myself, am I permitted to do that? When I took this image of a yeast flower, was I permitted to delete the Petri dish in order for you to see it clearly? That image of the bacteria, you see those were cracks. I deleted those cracks in Photoshop. Was I permitted to do that? I say to you, I am, if I tell you that I do it. That's, again, what removes me from the world of art. Another possibility that we should continue including in our discussions is the power of the visual metaphor. A CD, how does a CD work? Well, something like a piano player roll, on, off, on, off. It's the way we can talk to each other about things we don't necessarily understand. And finally, it is ultimately about speaking to the public. I had this exhibit on the Champs-Élysées. Why not scream to the world how amazing science is? I was not the first person to look at drawings or pictures. This fellow thought about it a long time ago. And the connection between the images and the text, of course, is vital. We only see what we look at. To look is an act of choice. I hope that I'm getting you all to start looking at science.